Hi everyone, welcome to thlympic. We are together again with another 4 questions from past papers of International Math Challenge. So let's start. So this is our first question. The question asks 100th digit or the third digit from right for this product. So one way we can just multiply it. Probably it will be longer if we finished all the multiplication. Another way, maybe while multiplying, you will see the pattern and you don't need to finish it all. You can just calculate the result. Or this is the way I did it. So instead of 99,999, I just wrote as 100,000 minus 1. So after that, when we I open the bracket. So we multiply outer term by each inside terms. So maybe we can write shortly the formula for those who doesn't know. So A, B plus C. So if A times B plus C, to remove this bracket, we multiply outer term by each inside term. So A times B plus A times C. So this is our rule for removing a bracket. So according to this, so there is here multiplication, but generally we do not write if there is a bracket. So we need to multiply outer term by each interior terms. So this is the first one, this is the second one, and after that we do the subtraction. So since the endings of both numbers are similar, so probably we will get a pattern as you see here. After first digit, it goes as 5, 5, 5, 5 until the zeros will finish. So this number I just wrote as this one. So since we cannot write 10, I just write 9 plus 1. So I got 1/10 and just distributed. So as we see, the 100th digit is 5. So for our second question, this is kind of like a puzzle or IQ question. So we have 6 sticks of same size, and using these ones, it asks maximum how many triangles we can do. So I just work on this shape, and we realize that there are 8 triangles and 8 is the maximum. So I didn't check more. So here 1, 2, 3, 4, 5, 6, the big one 7, and the other big one 8. So as you see, we have 8 equilateral triangles we can make using 6 identical sticks. So the answer is 8. The question number 3. So the question asks which one is the largest. So for this kind of questions, first thing, keep it in mind, like the exponential numbers grows very fast, much faster than normal numbers or polynomials. So if something is exponential, we should be careful. Probably it's a very big number. So according to this, like I just didn't think much about this, just I ignore this because this is just a normal number, but these are exponentials. So they will be bigger. So comparing A and C, in first level, I just canceled this, level 1. In level 2, I compared these A and C. For A, both base and the power smaller than C. So in the level 2, I just canceled A. Now I left with 2 numbers, so I want to compare these two. For these two, I just changed this. I wrote this in this way. So I get that 2, I divide this by 2, so I separate these 2 numbers as two different powers, because according to power rule, we can multiply these two and get the same number. So I rewrote this number in this way, and 21 square is something like this, approximately more than 440, I guess, or around this number. So as you see, I use approximation symbol, so this is not the exact result. So as you see, this power is more than 21, and the base is also more than 43. So definitely this number is much bigger than this one. So the largest one is number D. Here there are some rules, you can keep it in mind. If two exponentials are like, if one exponential is bigger than the other with the same base, but the base should be positive. For negatives, the rule may be changed. We need to be careful with negatives. So these are positives, that's why. And for the positive bases, the bigger power gives bigger numbers. Is it always right? Yeah, I think, no, this should be more than one. Okay, let's correct the rule. So we should be careful, really careful for this kind of things. So for the exponentials, numbers from 0 to 1, when you increase the power, number is getting smaller. So this should be more than 1. And for large numbers, yes, for large numbers, let's say these two are the numbers, like big numbers like 4, 5, 6, more than 1. So the bigger one at the top is generally bigger. So you can keep it in mind. For example, let's say this is 2, this is 3. Oh, for 2, 3, it doesn't work. But for the big numbers, it works. So maybe more than 2 and 3. So here we may keep a note. So AB are maybe more than, let's say, 5. So you can try for more than 5, probably it will work, but I think it will work. So you can just check. Okay, this is our final question. Here we have a continuous kind of fractions. It goes on and on. So it seems hard, but actually not that much if you are good in quadratics. So what we do is, if we consider the whole result as A, and if you just ignore the bottom part, top part, the blue part is exactly the same as the beginning case. So this is also A, because it goes to infinity. Just without these two and this one, then nothing changed at all. So this is also A. So we rewrite this expression as 2 plus 1 over A and equals A. I hope you got it. So the blue part is same as the bigger one, since it is continuous and infinite. So after that, to cancel this fractional part, I multiply both sides by A. So A times 2, 2A. When we multiply the A cancel, just one left. A times A squared. Now I got these two to the other side. So A squared minus 2A minus 1 equals 0. So to solve as a quadratic, so this is close, like similar to A minus 1 whole square, but this should be positive. So I just add 1 and subtract 1. In general, we didn't do anything because together they are 0. So still they are same. So this part gives us a perfect square, A minus 1 square, and negative 1, negative 1. Negative 1 minus 1 gives negative 2. So we end up with this expression. After that, I got to the other side and take square root of both sides. So when we get square root, we have positive and negative 2 options for this. And then take one to the other side. So for A, we have 2 solutions. One is positive root 2 plus 1, this one. And the other one is negative root 2 plus 1, this one or this one. These two are same, these two are same. So in this case, root 2 is bigger than 1, and this result will be negative. But here, all the numbers we use are positive, even though we divide it. So 2 plus something little bit more than 0, probably. So it will be 2 plus something. That's why our answer should be positive. So we choose this as the solution, not this one, because this is not a valid answer for this question. So the answer is A equals 1 plus root 2. So thank you very much. That's all for today. See you in our next video.